the different data types? So this is an example. So a parking manager has classified and counted the vehicles in a building as follows: cars, trucks, bicycles, and motorcycles. So now my question is, please evaluate if the columns are quantitative or qualitative, and decide if the columns are nominal, ordinal, interval, or ratio. So please guys, I'm gonna give you a couple of minutes so you can check and define whether the first column, what type of variable it is, and same thing with the second one. All right, so here we mainly have only one variable, which is the vehicle type. That's the variable that we have in this problem. Now that variable, it is clearly a qualitative variable, it's not quantitative, because the vehicle type is an attribute, right? So you just need to visualize the vehicle, I'm sorry, and you will check whether it is a car, truck, bicycle, or motorcycle. And once you do that, you can count them. These are the frequencies. That's what we call frequencies. We'll use a different notation for that later. But these are the frequencies, number of occurrences of each variable. So 150 cars, 25 trucks, and 15 bicycles, and 10 motorcycles. So we know that the column, the main variable here, it's a quantitative variable. Now my question is it nominal or ordinal? Is it nominal or ordinal? Let me show you the difference here, the definitions here.
Ordinal.
So someone said ordinal. What do you think, guys? Nominal. Most of you
Nominal.
said, why nominal? Why nominal? Why nominal? Most of you have said nominal, but why nominal?
I guess because we are classifying this with only car, truck, bicycle, motorcycle. Is no, we are not setting or something like car is better or truck is down. We are only classifying that the vehicles.
That's true. That's correct. There is no like a way. I mean, there is not like a natural way to arrange them. It doesn't make sense like a specific order. Like the car goes first and then the truck. It's not that simple. It's not that simple. You cannot just arrange them because it doesn't make sense unless you make a different definition. Like let's arrange them based on the weight, for example. So that's different. But just, I mean, if you're only given the vehicle type, naturally that variable doesn't have an order. So that's why it's a nominal variable. So that's correct. So what most of you said in the chat, Lina, Jose, Juliana, and Pedro, that's correct. Okay, so now we're gonna talk about frequency tables. There are two types of tables: on-group frequency tables and grouped frequency tables. So what's the difference between one and the other? On group means that each row of the table it's given only by a single output. It's only given by a single outcome. While grouped frequency tables means that in each row of the table we have an interval. Let me show you some examples and then we're going back. Please look at this table. In each row we have A, B, C, D, E, F. Please notice that there is only one value per row. So we are not grouping data. We're not aggregating data. It's only one outcome per row. But on the other hand, later on, we will see some tables where please notice that in each row we have intervals. So that means that each row will contain different values that are located within the interval. So in the group data, each class is given by different values, not by a single value. So that's the difference between group and ungrouped frequency tables. Again, in the ungrouped, please notice that in each row you have a single value, that's ungrouped, but in the grouped, you will have intervals instead of single values. Now, when are we gonna use ungrouped frequency tables? So mainly when we have discrete data and when that discrete data has few possible values. So if the number of values, the number of outcomes is limited, then it makes sense to use an ungrouped frequency table. But if we have continuous data or discrete data with multiple values with different outcomes, then we will need to group the observations because we don't want a pretty long a long table. We want a table that is capable to summarize the data in a meaningful way. So that's why we need to master when you use ungrouped or when you are going to use group frequency tables. In this unit, we're going to learn how to create, especially the group frequency tables, because the ungrouped, they are easy to create, but the group, they require some steps. Okay, in addition to the tables, we will go over some plots, bar charts, pie charts, dot plot, histogram, polygon plot, ogive graph, bivariate chart, Pareto chart, and box and whisker plot. Those are like the most popular plots that you will see. I will add some other plots later, but these are like the most relevant plots out there. Okay, so let's see some examples to create the tables and the plots also. So in the example, it says that a manufacturing company has 6 machines to perform 3 processes. A sample was collected with the daily number of failures in each machine and process. Develop a frequency table for the machine's usage. So this is the table that we're given. So let me increase it a little bit. I'm gonna zoom a little bit. So the information that we know, it's day, so in which day the machine was used, machine, so that's if the machine used was A, C, B, D, E, or F. The number of failures, this variable here, actually it's the process in which operation the machine was used. So there are, let me see, there are three processes, 1, 2, and 3. Okay, the question here is to create a table so we can find the machine usage. We want to know the usage of the machine, meaning in how many days each machine was used. So to create a ungroup frequency table, the first thing that we need it's what are the outputs. So here the variable is machines. So we list all the possible values for the variable machine. What are those values? A, B, C, D, E, and F. Those are the outputs or possible outcomes of the variable. That's a qualitative variable. So you just check which machine was used and that's it. Now, how can we summarize data? So now we introduce the concept of frequency. So we have the absolute frequency and relative frequency. What is the absolute frequency? It's just the number of occurrences of an outcome in your data. So that means the number of observations in this case is how many times we have the value of machine A in our table. So in how many days we're using machine A. So you need to count them. So here's 1 time. Here we have second time, third time, Please let me know if I'm missing. Fourth time, fifth time, sixth time, seventh time, eighth time, ninth time, 10th time. So 10 times I found. So that's why number of days here is 10. So that's the absolute frequency, number of times that an observation is repeated. So you have to perform the same thing for the other machines, machine B, C, D, E, and F. So you get the absolute frequencies. And of course, if you add them up, you will get that in total there are 56 observations or 56 days in our analysis, right? Okay, so in addition to the absolute frequency, we can find what is called the relative frequency. The relative frequency is just is the same value but expressed in a different format using a percentage. So for the absolute frequency, we didn't have the percentage format, but for the relative frequency, what we're going to do is that we're going to take the absolute frequency and we're going to divide it by the total number of observations. That's our n. That's our n. So 10 divided by 56, that's the 0.179. 15 divided by 56, that's the 0.268. And you can keep going until you get all the relative frequencies. So it is important that you always have to check whether when you add them up, the relative frequencies, they have to be equal to 1. And if you have the percentage format, it has to be equal to 100%. So this is an ungroup frequency table. It is a way to represent a variable in a more organized way. Please look that initially we had this table. The original table had 56 rows. The original table had 56 rows. It is difficult to analyze that initial table. Why? Because for us as human beings, it's complex to get an idea immediately. Like, okay, how many times was each machine used? But once we summarize it using the table, even though this is a very simple table, at least now you can get a better idea of which machine was used the most. So now, for example, you know the machine B and C, those two machines, they were used like 15 times each. So they are the most used, like heavily used, right? Now, on the other hand, machine F is the one with the lowest number of days in which the machine was used. Only 3 days that machine was used. So even though it's a very simple table, please notice that it gives us information. We can get some insights about the original data. So that's why these frequency tables are useful.
Teacher,
Yes.
what represent that percent?
So this is the percentage is just a different format of the absolute frequency. So for example, the 26.8% means that out of the total number of days, out of the 56 days that we observed, we know that in 26.8% of those days, machine B was used. That's the interpretation of the percentage. So for example, for machine F, which is the machine with the lowest usage, we know that only in 5.4% of the days that machine was used. So it's just a different way to represent the frequency. Better?
Yeah.
Okay. So once we have created the frequency table, now it is possible, or it's easy to create plots, to create charts. So one of the first charts that I'm pretty sure that you have used this chart before is the bar chart. The bar chart. In the bar chart, we're summarizing the same data. So we know, for example, the machine A, the frequency is 10. So in the x variable here in the x-axis, we have the values of the variable. So machine A was used 10 times. So in the y-axis, this is the y-axis, the frequency, we have a 10 here. So the frequency will give you the height of each bar. Then we have machines B and C, and we know that the height here, or the frequency, is 15. 15, right? So using the frequency table, you will be able to create easily the bar chart. Again, it's just a different way to visualize your data. It will give you the same information as the frequency table, but maybe it's faster to spot which is the machine with the highest usage and which is the machine with the lowest usage. So just by looking at this plot quickly, you know that machine F has the lowest usage, while machines B and C both have the highest usage. There are other types of plots. So this is a pie chart. So using the same information. So we have the machines, the frequencies. With that information, we can split the pie. You know that the pie is like a cake, same thing. So to slice that cake or to slice that pie, we only need to compute the angle. So in total, it has 360 degrees. So we just need to split the pie by multiplying the 360 times the relative frequency. So 360 is the whole thing. But now if we multiply by the relative frequency, it will give us which is the angle that has to be assigned to each outcome. So for example, for machine A, it requires 64.3 degrees. Now, the machines B and C, which you already know, are the machines with the highest usage. Please notice that both, they have the highest angle, 96.4. And of course, machine F, the one with the lowest usage, has the smallest angle, which is only 19.3 degrees. So once you have computed those angles, you will be able to create the pie chart, which again, it represents the same information. It's only a different format, but again, it's the same idea that is expressed by the bar chart. Guys, do you have any questions so far? Do you have any questions so far? Okay, so let's keep going. Let's go to a second example. All right, so using the same information, a sample was collected with the daily number of failures in each machine and process. Develop a table for the number of failures. So please notice that in the same table, the third column, the variable, its number of failures. My question here, guys, is what type of variable is this one? What type of variable is this one? That third column.
Quantitative.
That's true. It's quantitative variable. Now, is it continuous or is it discrete?
Discrete.
Discrete, right? It's a counting process. It's a counting process. So the way we find the variable is just by counting the number of occurrences, right? The number of occurrences. All right. So how are we going to create here the number of failures? So for example, the first day, the company experienced 0 failures. So now you need to find in how many days we have the 0 value registered. So here we have a second one in day 4, in day 5. So you have to keep going, counting in how many days the company had 0 failures. Then in how many days the company had 1 failure, 2 failures, up to the maximum value of failures, which is, let's find it. I think it's 18. It looks like it is 18, right? The maximum number of failures. Yes. So for each number of failures, you can compute or find the absolute frequency, number of occurrences of the variable. So here we have number of failures, 0, 1, 2, 3, up to 18, right here. That's the last value. That's the last value. Guys, are you still, can you still see my screen? Okay, okay. Because I'm checking on my cell phone. According to my cell phone, I cannot see what I'm presenting right now, but that's fine. As long as you see what I'm showing, that's fine. But please let me know if something wrong occurs. Okay, so as I was saying, here we have these are the possible outcomes of the variable, right? Possible numbers of the variable. So it goes from 0 to 18, right? It's a discrete variable, as you said. It's a quantitative variable. Now, once we know the outcomes, we can compute the absolute frequency. So in total, if you check the table, you can go back to the table anytime. You will find that there are 16 zeros, meaning that in 16 days, the company experienced 0 failures. So if you keep going until the last one, in total there are, again, 56 days registered, right? It's the same, that's the number of observations. With the absolute frequency, you can compute the relative frequency, which is just the absolute divided by the number of observations. So 16 divided by 56, 3 divided by 56, 9 divided by 56, 2 divided by 56. And that's how you get the relative frequency. It just gives you an idea of the percentage of days or percentage of occurrences. So we can get the same bar plot here. So remember that the bar plot shows the frequency of each outcome. The height of each bar represents the number of occurrences. So here, for 0, the variable equal to 0, we have 16 occurrences, right? That comes right from our table. So someone is asking, can I delete the days that don't have failures? You don't have to delete them because actually we're counting. Remember, I mean, the variable equal to 0, it's a possibility. And here, if you notice, actually, that possibility is the one with the highest frequency. So it is relevant. So we have to keep the 0, of course. We have to keep the 0. All right. So the bar plot, again, summarizes the same information that we just visualize in our table. But here, you can check easily which is the value of the variable with the highest frequency, that's 0, with 16 occurrences. And in addition, you can identify quickly which are the values with the lowest observed frequency. In that case, that will be 4, 13, 15, 17, and 18. All of them with a frequency equal to 1. But if I almost missed this too. Actually, 10 and 11, both, they have 0 frequency. That means that in none of the days that we observed, we experienced 10 and 11 failures. So this type of analysis can be performed using the bar plot. A similar plot is the dot plot. It looks similar than the bar chart. It shows the same information. It shows the same information, only for the number of failures. Each plot represents 1 observation. Each dot represents 1 observation. That means that here, for the 0, we have 16 observations. So if you count, you should have 16 dots, right? So again, it's the same. It's just a different format, but it's the same information that is presented by the bar plot. The histogram looks similar to the bar plot. In the histogram, you have bars, and in the y-axis is the frequency, and in the x-axis, we have the variable. So they look pretty much alike. They are pretty much the same thing. The histogram and the bar chart. There are some differences. If you look the format, please notice that here in the bar plot, we use space between bars in the bar plot, and in the histogram, there are no spaces. Now, why? And I will give you a quick way to make a difference between the bar chart and the histogram. The bar chart or bar plot is mainly used when you have qualitative data, like the machines. For example, here in the machines, this is qualitative data, so you use bar chart. If you have discrete observations, the bar plot may work. If you have continuous data with intervals, then for sure the histogram is the one that you're going to use. So again, the bar plot is mainly when you have qualitative data or discrete values. And the histogram is going to be used mainly when you have group data, intervals. That's when you cluster together all the bars. But at the end of the day, they look similar. They will give you like the same information. The polygon plot is just a different way to represent the same thing. So how does this work? So for each value of the variable, for example, variable is equal to zero failures. So you just need to plot one dot, frequency 16. For this one, the frequency is 3, frequency 9. So you keep going. You just plot the dots, and then you connect the dots. So once you connect the dots, you will get the polygon plot. It's a different way to represent. It's a line. It's just a line. And it's useful when you want to see like some trend, for example. So that line is gonna show you in a better way if there is a trend in your observation. Maybe like as you increase the number of failures, for example, the frequency decreases. Maybe that's an interpretation that we can make here, right? So if I have like a smooth line here, so maybe analysis might be like as the number of failures increases, so we have like less frequency. So it was less frequent to observe that number of failures. So that might be the type of analysis that you can perform using this polygon plot. Guys, do you have any questions so far? Questions?
All clear, teacher.
Okay, guys. Thank you for that. All right, so what's next? Now we have the group frequency tables. And remember that they are different than the ungrouped frequency tables. So before I proceed to the group frequency table, I don't want to like spend a lot of time in each video. So I don't want to like speak for more than 1 hour per video, because I think that's too much. That's just too much. So what I'm gonna do right now, guys, is like I'm gonna stop this video and I'm gonna proceed. I'm gonna show you R a little bit. So maybe I want to keep you a little bit more activated. I want you to see how it works, the software. Maybe it's more interesting for you to visualize how you can do things on your own. Maybe a more interesting analysis. So let's do that. So could you please, I don't know who's recording the session, but I'm gonna ask you guys to please stop the recording so we can move and we can start a new video for the R part. So could you please stop the video, someone? You just have to, I don't know who,